involves the primary. You make sure you really know the chromosome numbers. This is going to be important. I'll show you a slide on it. But like the oogonium and spermatogonium are like stem cells, and they're 2N. The we're talking about the female stuff here. The oogonium develops into a primary oocyte, which is 2N. Meiosis begins. The secondary oocyte is N. Then the ovum there is N. Let me show you. Let me just kind of show you right here. Oogonium 2N, primary oocyte 2N. And here's the thing about it. There are 700,000 of those things. Did we go over this the other day a little bit? I don't remember. 700,000 of those in a female baby at the time of birth. And only, I have here, only 400 or 400 or 500 will be used. That means ovulated during that female's lifetime, during her reproductive period. Okay? So 700,000 of those at birth. That's hard to kind of imagine. All right? And then this will just say meiosis 1, secondary oocyte structure, and there it is, just telling you, re-emphasizing that is the structure that is ovulated and and arrested in meiosis 2. Meiosis 2 completed, only if fertilization occurs, and then I have down here, and make sure you do understand, I think you understand, if fertilization occurs, then that secondary oocyte will divide through a mitotic type of event, divide into the ovum and a polar body, and the polar body disintegrates in most situations, okay? So that I just had that, and there it is. This oocyte completes meiosis 2 to form the ovum only if fertilization occurs. Sperm and ovum swell to become the male and female, and they use the term pronuclei, and the true moment of fertilization occurs when the paternal and maternal chromosomes combine to produce the diploid zygote. And so that is the idea of that. And then I think I show you right here. See, this shows. I think this is from. I don't think this is from your book, but that's just kind of showing the scenario. See, that secondary oocyte divides. It gives rise to one polar body. That polar body divides into 2 more. All these things disintegrate normally. Here's the secondary oocyte. That's ovulation. There's the secondary oocyte. There's the spermatozoa, or sperm cell. If fertilization occurs, now, only if fertilization occurs is meiosis completed and a secondary oocyte forms. That thing disintegrates, and it only becomes an ovum or an egg if fertilization occurs. That's the way the biology is. And and so there you kind of have the scenario of how that is working, how that works out. And so, does anybody have any questions? There will be a question on your final exam about chromosome numbers. Make sure you know that like spermatogonium and oogonium, these are the stem cells, they're 2N. To take one at a time. The oogonium gives rise to a primary oocyte, which is 2N. Primary oocyte undergoes meiosis, gives rise to a secondary oocyte, where it doesn't complete meiosis unless fertilization occurs. And so there you just kind of have a little scenario of that stuff right there. And so that's just kind of, part of it. Now, the uterine tubes, they're also called fallopian tubes, obviously. The uterine tubes are about 4 inches long. These things are, now, here's one thing I want to mention about the fallopian tube. It's just like in the vas deferens. The distal end of the vas deferens is called the ampulla of the vas deferens. The ampulla is we even use that term in 2401 in the semicircular canals. The ampulla of the semicircular canals. That's the swollen kind of base of them. So the ampulla is the distal expanded end of the tube. And that's all ampulla means. Infundibulum is the opening. And some of this will be on your phone. The infundibulum is the opening, and at the end of the infundibulum, there are these finger-like projections called fimbri, F-I-M-B-R-I-E, fimbri, and these, of course, work to draw the oocyte toward the secondary oocyte toward the tube, and so the finger-like projections, they move in order to create and that's a wrong term right there. I need to correct that. That's just a wrong term right there. And I don't know why I didn't, to draw, that should be, where's my thing? I'll correct it on my computer. That shouldn't be to draw the egg. That should be to draw the secondary oocyte. So correct that right there, and I should have, I wish I had corrected that. Here we go. So if I were to, oh, I'll do it when I draw the secondary oocyte. Tubes, the common site, obviously, for ectopic pregnancies. An ectopic, in case most of you know what that term means, ectopic literally means out of place. That's all that term means, out of place. And then we have that sort of thing, ectopic, and of course those are a problem. Ovulated oocyte, and I think we talked about, did we talk about this a little bit last time? Y'all don't remember, do you? Has it been too long ago? You do remember? We mentioned it, okay. And so I just had right here, it doesn't hurt to repeat it, because this stuff goes pretty fast, and most of it, there are a few little technical things you don't know, but, you know, for the most part, the ovulated oocytes are cast in the peritoneal cavity, and I said many are lost there, also microorganisms, STDs. That STD, sexually transmitted disease, is what that occurs, that means, and a key one in the US of A right now is chlamydia, and, you know, this can lead to pelvic inflammatory. So that's just kind of showing the setup right there. Now, remember, here's the ampulla of the uterine tube. The narrowed area is called the isthmus of the uterine tube. We did talk about this. There might be some questions on some of this. Definitely know that the fimbriae are these finger-like projections. Make sure you understand that. This is showing the endometrium, myometrium. Now, the perimetrium is the same thing as the visceral, the perimetrium, same thing as the visceral peritoneum. That's the perimetrium. That's the outermost layer. And then there's ligaments associated with all that in female internal reproductive stuff. Okay, so there we have that. Now the uterus, inverted pear-shaped organ, obviously, has a fundus, a body, and a cervix. Cervix is the neck. Now, make sure you know what cervical dysplasia means. What does cervical dysplasia mean? How many of y'all know? Y'all were sleepy this morning. Y'all were sleepy. I was glad to get back here and all that work I was doing at home. Yeah, man. Oh, God. All right, the inverted pear-shaped organ, that is the uterus. And what did I ask you? The dysplasia, cervical dysplasia. What did you say, James? No. Cervical dysplasia is abnormal cells. Cervical dysplasia, they will look, if you have a pap smear, you females, and they say, well, we need to come back because we see some dysplasia. And we need to examine these cells a little more. That can be a warning for cervical cancer, cervical dysplasia. You know, and so we had a woman that worked for us. Her name was Carolyn Loomis, an older woman. She has grown children that worked for me and my dad many years ago. And she went for a pap smear one time, and she came to me and said, I think they identified a situation called, they called it cervical dysplasia. What is that? And I explained to her, but she went back and had that checked out, and she did not have cervical cancer. She was fine. She was okay, just a little abnormal. And I don't remember, it's been too many years ago, I don't remember if they did recommend a hysterectomy or not. I don't remember, but that's that. Functions, of course, the uterus and menstruation. Remember, y'all do remember this, that the menstruation is the stratum functionalis of the endometrium. Make sure you know that. The menstruation is where the stratum functionalis of the endometrium is, quote, if you want to use this term, sloughed off or discharged. That's the stratum functionalis of the endometrium. And of course, it's involved in the development of the fetus during pregnancy and labor. All right, so there's that. Uterus is held. Now, I'm not going to ask you all these ligaments, but it's held in position by a whole bunch of ligaments. The broad ligament, the round ligament, you know, cardinal ligament, uterosacral ligament, but there are ligaments involved. I might ask you something to the effect, what stabilizes the uterus in position? Now, Jamie, you weren't here the other day, but I bet you know this term. Do you know what retroflexion and anteflexion has reference to? You ever heard those terms before? That can interfere with, say a woman wants to get pregnant.